All right, welcome participants for today's training session on SPSS. It is 25th training day covering the intermediate part on online training of SPSS. Myself, Zahid Bashir, I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab. So, the contents we have covered so far are indicated in yellow, and the last session was comprised of regression assumptions or diagnostic. So, today we are going to start our sessions on regression cases. Uh, these cases includes the type of dependent variable. Whenever the type of your dependent variable changes, it changes the case of regression, the specific case of regression. So today we are going to cover what specific cases we need to deal with. So this is the tabulic representation of the cases that we are going to cover under this training session. Uh, the first case represent the simple regression analysis where your independent variable is quantitative and your dependent variable is also quantitative. All our previous session basically has covered case one and case two, because the case two, in case of case two, the independent variables are also quantitative because we have used only the quantitative variable in our all previous cases. So in case number one and in case number two, your dependent variable is quantitative and your independent variable is are also quantitative. While in case of simple regression analysis, there will be one independent variable, while in case of multiple regression analysis, there might be more than one independent quantitative variable. So we are directly starting from case number three. This is the special case where your independent variable is basically binary variable and your dependent variable is quantitative. I have shared some data with you with both of my participants. The data is with the name of data sets. And if you open this data set here, you will find our data set with regression case number three. So for discussing the particular case number three, we need to use this data set. So I am going to open this data set. And meanwhile, it is open. I need to discuss with you what is this data set and how we are going to use this data set. So case number three is basically relevant with independent variable binary, while dependent variable as a quantitative or continuous. So we are going to test this hypothesis. Is there any effect of gender on salary? So our null hypothesis would be there is no effect of gender on salary, while alternative hypothesis is there is a significant effect of gender on salary. So your gender variable needs to be binary, 0 and 1, and salary variable needs to be quantitative. So the gender variable with 0 indicates no impact, while the gender variable with 1 indicates there is an impact. So if we have assigned 1 to the male and 0 to the female, it means we are interested to predict the impact of male as a gender on salary. So you need to understand this logic that 1 indicates an impact. So whenever a variable is coded with 0, it means there is no impact. And whenever a variable is coded with 1, it means there is an impact. So let me show you the data set. This is the data set that you can see here. Let's suppose I basically delete the remaining part, which are not necessary here. Now, let's suppose this is the data set. Here you have gender variable and salary variable. And if you see, in case of gender, you need to point out that uh, the gender is represented by male and female. So you need to indicate what does it mean by male and what does it mean by female. So you can change your variable into one and two. For example, if I am interested to find out the impact of male as a gender, I can convert this data of male into one. And if I am interested to consider the impact of female on the salary, I may convert the female into one and the male into zero. So you can convert it. For example, I am interested to consider the impact of male. So wherever the male is written, I can write one. So you need to write one in place of male like this. So you can put it manually. It is a very easy procedure like this. So simply wherever male is written, you can put it one because we are interested in order to find out how the gender which is represented by male impact is basically impacting the salary. So we simply need to put a male for the impact like this. After coding one as a male, you need to code zero for female. Wherever female is written, you can code it with zero like this. So it is up to you. It is based on your research objective. If you are interested in considering the impact of male as a gender for salary, you can code male as a one. If you are interested to measuring the impact of female as a gender on salary, then you can code one for the for the female and zero for male. So always remember that one represents an impact, while zero represent there is no impact. So always remember the logic of the statistical analysis when we are dealing with a specific case. So I will let you know the three types of analysis here, that how to put that analysis into as per your objective. So in case of gender, I need to put here the values. So value of one represent males and value zero represent here female. So as I have already told you that one indicates an impact. So here I am interested in order to know the impact of male as a gender on the salary. So what I need to do, one for male and zero for female, click OK. After doing this, you go to analyze, you go to regression, linear, and you need to put salary as a dependent variable and gender as an independent variable. It is showing that it is string variable. We need to consider it as a numeric. Click on OK. Some values label or missing value specification will be discarded for gender. All right. So we go to analyze, we go to regression, linear. We need to put salary here and gender here and click on OK. And it will show us regression results. R here is 2.9%. Model is not statistically fit because this sig value is greater than 5%. And if here you can see the impact of gender is positive, but it is weakly significant. So if you are specifically interested for male, what you need to do in order to consider the difference impact of male and female, you can create their dummy variables. So go to transform and go to recode into different variables from here. So I put gender variable here. I put dummy male. So the male change old and new values. So old value is 1 and new value is also 1. Click on add and all other values are 0. Because I want to see the impact of male as a gender. So 1 represent the impact while other values are indicated by 0. So click on continue. Your first dummy variable will be computed here. You can see here, this is the dummy variable. You can also find out the values. And if you are interested in also creating the dummy for female, go to transform, recode into different variables. Now, first of all, you need to reset this setting. Then you need to put the gender into this and create dummy female. Female. So the female change old and new values. As we already know that female is represented by 0 and we are interested now for the impact. So we can put 1 as a new value and we will consider all other values as a 0. So this is how you can create your dummy variable. 0 is the old value and 1 is the new value. So it is representing the impact. So click on OK. So it will also generate another dummy. So you can see here. So this is the dummy female and this is the dummy male. So if I am interested in order to know the impact of male, I can run this one on salary. And if I am interested to know the impact of dummy female, then I can run this one on salary. So for your analysis procedure, we can run the impact of both dummy variable on our salary variable. So salary is here. We need to put here the dummy variable male and dummy variable female. So these will indicate the separate impact of male and female. So you need to click on OK and you will see here the R square is same. The model is still same. And here you can see the dummy female and they have excluded variable dummy male from here. Why they have excluded? We can consider the impact separately. Maybe they were not considering the combined effect. We can consider the impact of male first of all, then for female. Click on OK, and you will see this is the impact of male. And here you can see the impact of male is positive and weakly significant here. The model is not fit because this sig value is greater than 5% and R square is 2.9%. Now I am interested in order to know what is the impact of female here. So rather than putting the male, I can put here the female instead and click on OK. It is showing me the same impact, female impact, but this impact is negative, while the previous impact is positive. So we can simply consider the combined impact here. This one. This was the combined impact. No, this was this one. This one was the combined impact because it is showing the same result. So you can consider the case number 3, that gender weakly impact the salary, because here you can see that the impact is very weak. It is about 10%. It is, if it is less than 5% or less than 1%, then we can say that the impact is positive and highly significant. But here, in this case, the impact is weakly significant. Now, the next case, the fourth case is the simple regression analysis. Here, categorical, more than two categories dummy variables, and we have the quantitative dependent variable. So this is the case number 4, but before analyzing this case, you need to understand the specific detail of this case. The case number 4 contains categorical independent variable. It means your independent variable may have more than two categories, and your dependent variable is quantitative or continuous. So, as a researcher, I am interested to know, is there any effect of employment categories on salary? So, you will be provided a data set, and you will be provided employment categories as a independent variable, where there would be more than two categories. So, the hypothesis is there is no effect of employment categories on salary. And alternative hypothesis would be there is a significant effect of employment categories on salary. So we need to understand whether our null hypothesis would be accepted or not. So your employment categories variable need to be categorical, 1, 2, 3, and salary variable need to be quantitative. Always remember that whenever you have some categorical variable, it means more than two categories, then you need to create the dummies by considering this formula, n minus 1. N stand for number of categories, and minus 1 stand for that you need to create how many dummies for your categorical variable. So as there are three categories, in case of your independent variable, which is employment categories. So there are three categories. Therefore, we need to create two dummies, because n minus 1, 3 minus 1 means we can create two dummies, and we can consider one category which is excluded for the creation of dummy as a reference category. So these are the three categories of your independent variable, that is employment categories. So clerical, custodian, and manager. We need to consider one of them as a reference category in order to analyze their impact on salary. So let's have the manager as the reference category and create dummy variable for clerical and custodian. So if we consider manager as a reference category, we need to create dummy variable for clerical, and we need to create dummy variable for custodian. So let me show you the complete procedure. Let me consider the impact. First of all, we need to open the next data set, that is regression case number 4 data set. This data set would be used for case number 4, so that you may be able to understand how to analyze this data and how to consider the reference categories and other categories. So if you see here, there is a variable named salary, and the other one is job categorization. If you open the variable view, here you can see the job category with the values. If you open it, you will see three categories of job. So we need to consider manager as a reference category. So we can create a dummy variable for clerical and custodian. So their old numbers are 1 for clerical and 2 for custodian. So we go to transform, we go to recode into different variables. So job categorization, we need to put it here. We can write here dummy hyphen clerical. The first category is clerical. So D, clerical, and click on change. Now you need to put old and new values. Always remember you need to verify what are the values are here as a reference category. For example, if you need to see the clerical number is represented by 1. So 1 is the old number. So we need to consider for the impact as a 1. So what we have done now, we need to again create it because we didn't create it. Dummy, clerical, D, clerical. Change old and new values. So old value was 1 and we are interested to see its impact. So we will consider 1 as a new number 2 and the all other numbers we consider as 0. So we will consider 0 for all other numbers. Click on continue and click on OK. So one dummy variable for clerical is being created. Now, if you see here, the other dummy variable is custodian because manager is considered as a reference category here. So we don't need to create any dummy variable for manager, but we need to create another dummy variable for custodian, which old number is 2. So we go to transform, go to recode into different variable, reset, put the job category again, and write here dummy custodian. That is the second dummy, the custodian, change, old and new. Old number is 2, and as we are interested in its impact, so we will consider 1 for it, and all other numbers are considered as 0. So click on continue, click on OK. It will generate the second dummy variable. You can verify this is the first dummy variable. This is the second dummy variable. Now, what you need to do, you go to analyze, you go to regression, linear regression, and then you need to put your dependent variable, which is salary, and your independent variables like this. Now you click on OK and it will show you the results. Here you can see the R square is 64.9. It is approximately 65% R square. So it indicates that the clerical and the custodian category, the clerical and custodian category explains 65% variation in the salary. And if you see the SIG value of ANOVA table, it is less than 5%. So it means the model is statistically fit. And here you can see the impact. So clerical category is negatively influencing the salary. It means the salary will be decreased by this number if we consider, and if you can see here, there is a value in front of constant. It is basically the value of your reference category. As you remember that our reference category is manager, it means that this value is relevant to manager. Specifically, this value is relevant to the salary of the manager. So as compared to the manager salary, which is 63,977.798, the clerical staff is receiving salary less than 36,138.018 as compared to manager, and it is statistically significant. In the same way, if you can see the salary of custodian, it is also showing the minus sign. So as compared to the salary of the manager, which is 63,977.798. The custodian staff is receiving a salary which is less than the managerial salary, 33,038.909. So custodian staff salary is basically decreased by this value as compared to the managerial staff. And clerical staff salary is decreased by this value as compared to the managerial staff, and both are statistically significant. So this is how you can apply the independent variable, which is basically categorical variable for considering this case. Now, the next thing that you need to understand, this is the procedure that I have adopted. I will let you know the whole procedure again. So how I have considered, I put the job category here, and then I created the dummy variables, and then like this, write the category of your first dummy variable, uh, click here to record the values. This is the old number. This is the already given number in value labeling. This is the number which is basically used for the impact. As I have already told you that one will be used for the impact. So I click on add to proceed, then I click on all other values and place 0 for it and click add again. So this is the procedure that I have adopted for creating the dummy variable. Then I created another dummy for the second category, and I have created both of them using the same procedure like this. So select both of them and remove, and we have created the second dummy using this procedure. After creating the dummy, we have now we need to run the linear regression that we have already done with using the procedure that I have already prescribed. So this was the result that we have interpreted already, we have discussed. So there is a case number 5 where your independent variable is quantitative while your dependent variable becomes binary. So let me show you the data for this so that you may be able to apply this procedure. So we need to open this data set. Data for case number 5. Once it is open, we will be able to evaluate this condition. So this is the data that is provided to you. For example, these are the files that I have already created, but you need to make them clear because these are the things that we need to calculate using the manual procedure. Now, this is the data that you actually need for your analysis. That is the age and status. So what does it mean by age and status? The question here is there any effect of age on status of heart disease? So as we already know that with the passage of time and by increasing the age, a lot of people had to face some kind of heart disease. So I am interested to know whether there is any effect of age on status. All right, there was a temporary interruption of internet. I was discussing the case number 5, where I was interested in knowing the impact of age on status of heart disease. So the null hypothesis was there is no effect of age on status of heart disease, and the alternative hypothesis was there is an effect of age on status of heart disease. So when your dependent variable becomes binary, it does not matter what is your IV, it will require logistic regression. So always remember that the whenever your dependent variable becomes binary, you need to use logistic regression. Uh, and do not consider independent variable because independent variable does not change the method, but the dependent variable changes the method. So whenever your dependent variable becomes binary, you need to use the uh, binary logistic regression. So step one is to run the binary logistic regression, dependent variable status of heart disease and independent variable age, and establish a predictive regression model. Then we need to calculate the following: z, negative z, exponent z, inverse of z, z distribution of your predictive model, negative z, exponent z, 1 plus exponent of z, and 1 divided by exponent of z. Then we need to create scatter plot for probability of heart disease. So you need to understand the step-by-step procedure. So first of all, we need to run the binary logistic regression. Using the same procedure, we need to put the heart disease status as a dependent variable and age as a covariate. And we can uh, take the results from block 1, where we can see the significance value and we can see the Cox and Snell R-square value. And after that, always remember that the omnibus test of model coefficient should be less than 0.05. So we can conclude that there is an impact of age on status of heart disease. Then from model summary, we need to see the Cox and Snell R-square. The Cox and Snell R-square value indicates that variation in the status of heart disease is 25.4%, is explained by the variation in age. So then we see the classification table. It will indicate us a number of values here, like it will indicate the overall percentage of correct prediction, which is 74%. And then we will see the beta values. The beta values are indicating here whether they are significant or not. So age in years is indicating that it is a significant value. And then we will see the exponent of B. There is an effect of age on heart disease status. With 1 year increase in the age, there is a 1.117 times chance of having a heart disease. So this value will indicate the chance of having a heart disease. So use these coefficient values for your predictive regression model. Then we need to create the predictive regression model. And after that, we will consider a very long procedure, which is known as the calculation of z distribution using this. Then we will consider the negative z distribution case. Then we will consider the exponent negative z distribution case. Then we will create 1 plus exponent of negative z distribution case. Then we will consider 1 divided by 1 exponent z distribution case, and then we will run a scatter plot using simple scatter, and we will put probability of heart disease as an independent variable and age in years as a dependent variable, and we will create a graph like this, which will show us that with the increasing of the age, the probability of having a heart disease will also increase. So we will consider this in the next session, because this procedure will require with us at least 30 minutes. So as the time for today's session is going to end, so we will consider the case number 5 in detail on Monday, because this procedure will require at least 30 minutes. So as our time for today's session is going to end, so we will consider this procedure on Monday. So do you have any question up to case number 4? You may ask. Yes, Miss Hina and Miss Rabia, do you have any question?
No, sir.
No,
All
sir.
right, all right. So we will consider the case number 5 in detail on Monday because it will require a lot of time. It requires a lot of steps. So we will consider more specifically case number 5 and 6 on Monday. So thank you for joining and stay blessed.